In this lesson, we're going to focus mainly on sampling distributions. We want to come up with a sampling distribution so it can help us make predictions about our population. So for the big picture, once again, we have our population, we end up getting our sample, a random sample, hopefully, and then we make statistical inferences about our population. A statistical inference is a process of drawing conclusions about the population based on our sample. Now, parameter is something, a number describing our population. Parameter begins with P, population begins with P. A statistic is a number that is computed from our sample. Statistic begins with S and it comes from our sample, which begins with S. We usually have a sample statistic and we want to make an inference about the population parameter. We're using our information about our sample to make a prediction about the population. So population deals with parameters, samples deal with statistics. So here we go. We have some of the things we've looked at so far: mean, proportion, standard deviation, and correlation. We have the symbols are for our parameters, our population, and we have the corresponding symbols over here when we're dealing with our statistics, which is from our sample. So for each one of the following situations, state whether it's a parameter or a statistic. Average in all households. So it would be a parameter. Being an average, it would be mu. Correlation between the heights of all players on a roster, that would be rho. Proportion of people, and it's a sample, that would then be a statistic, and it would be a p hat. So we have two parameters, and the bottom one is a statistic. So before the 2012 presidential election, 1,000 people were asked who they planned to vote for. And we had 50% for Barack, 44 for Mitt Romney. So what proportion of voters plan to vote for Barack Obama? It would be a p hat is 50%. In reality, for that situation, your proportion of your population, it was 51.06%. So we use statistics from a sample as a point estimate to estimate something about our population parameter. So what it is we are collecting from our sample or of our data for our sample is a statistic, and we're using that to estimate what's going on with our population. Point estimates typically do not match your population parameter exactly. It's our best guess, and normally they're relatively close. But if we look at a few others of that presidential election, you'll notice that Barack Obama was 49% here, 50% here, 52%. And you'll notice what it is for Nip, Nip Romney. Now, you'll notice when you look at the Barack Obama, they're all fairly similar, but they're different. So they're giving us an estimate. And these sample statistics will vary from sample to sample and will not match our parameter exactly. So here's our key question. For a given sample statistics, what are the plausible values for our population parameter? And how much uncertainty surrounds that sample statistic? Well, that all depends on how much our statistic varies from sample to sample. So we want to end up taking many samples. We want to sample, get that statistic from that sample to another sample, and do that statistic and do that many, many, many times. When we plot all these statistics from all our samples, we get a sampling distribution. That sampling distribution from all those different samples for our same population. The sampling distribution will vary from sample to sample, but the center of our sampling distribution should be the center of our population parameter. The shape of most statistics that we will be considering, if the size is large enough, will be bell-shaped and symmetrical for our sampling distribution. I'll be showing you stat key here a little bit later on another video. So just be aware, we want to take random samples, and if we do that, our sampling distribution should be centered on our population parameter. However, if you have a biased sample, your sampling distribution will give you bad information about your parameter. Now, we've learned about the center and the shape. And remember, what we're really concerned about is the variability in our sampling distribution. We need to know what is the uncertainty of our statistic. How much does it vary from sample to sample? Now, this variability is so important it gets its own name, and it's called standard error. The standard error of a statistic is the standard deviation of that sample statistic, or the standard deviation of that sampling distribution. It's a standard error measures how much your statistic varies from sample to sample. And it's, once again, the standard deviation of that sampling distribution. Now, size matters. The variability of our sample statistics tends to decrease, and the sample statistic tends to get closer as the sample size increases. So the bigger the sample, the better the data you get and the less variability you get because it's a larger sample. Larger sample sizes, you get less variability, so you get less uncertainty. So inferential or statistical inference is drawing conclusions about your population based on your sample. We use our sample statistics to estimate our population parameter. Our uncertainty of our statistic is our standard error. That's how much it varies from sample to sample. And we use this to create our sampling distribution.